Hello all, today in this video I'm going to work with ANN algorithm, and already with the same model we have worked with multiple optimizers, and here we are going to work with Adadelta optimizer and going to make an comparison. For that, initially we are importing the data libraries which we are needed. Then the data set, we have used the heart disease prediction data set only. This data set we downloaded from Kaggle. It has nearly 14 entries. Among that, the first 13 entries we are using as the x variable, and the last one entry, that is the target variable, we are using as the y variable. Then we are getting the info of the data set. From that we are getting that the first all the things are integers apart from old peak, which is and float one. Then we are describing our data set, and then we are checking whether our data set is having any null entries. Why? Because if it is having any null entries means we have to make some pre-processing functions. Then we are plotting the SNS heat map of the data set. So this is the heat map of the heart disease data set we just downloaded from Kaggle, and now we are just using to determine the variables like xtrain, xtest, ytrain, and ytest. For that, we are using the x variable and y variable, and x variable, as I said, we are using the first 13 variables. For that, we are just dropping the last variable. Then for the y variable, only the target variable we are using. Then by using this x and y variable, and the test size is 0.2, that is 80-20 per split, that is 20% will be allocated for testing and the remaining 80% for training. By this we are determining variables like xtrain, xtest, ytrain, and ytest, and then we are using the scalar to just convert the data into vectors. Here only we are converting the xtrain and the xtest function, then we are getting the shape. Why? Because based on this shape only we will use as the input dimension for the ANN model. So first, the ANN model will have nearly 4 layers. The first is the sequential, next is the 3 dense layers. Among that, the 2 dense layers will have the output dimension as 11 kernel. Then the every dense layer will have the kernel regular initializer as a uniform, and then the activation as ReLU. The input dimension is 13, which this 13 is from the xtrain data shape 13. Then the last dense function is having the output dimension as 1. This is because our data is an binary classification work. For binary classification, we will put the last dense layer as 1. If multi-classification means based on the classes, we will just give it as 3, 4, etc. Then we are compiling our model. In this case, we are using the Adam optimizer, loss as binary cross entropy, metrics as accuracy. Then here we are using the early stopping function. This function will monitor the validation loss if the validation loss is not changing for the 10 approaches. Why 10 approaches? Because here we have given patience as 10. If you want some less or more approaches means you can just change this patience value. Then we are just training our model by using the fit function, and with the variables like xtrain, ytrain, validation data we are using as xtest and ytest, approaches as 50, and we are also calling callbacks within this early stopping. Then for 50 approaches we are working with, and we are getting the accuracy, validation loss, validation accuracy, and accuracy. We are predicting our model and getting the classification report. For Adam optimizer, we have got an accuracy of 91%. We have also declared the variables like precision, recall, F1 score, and support. Then we have made a definition for confusion matrix. In that, we are just making the title, X text, Y text, text layout, etc. Then we are just computing the confusion matrix by the variable Y test and Y prep, and then we are displaying the confusion matrix for the Adam optimizer. Then we are working with the SGD optimizer. Every variables are same only, every layer composition is same only. Only thing is differing is the optimizer previously we will be using as Adam. Here we will be using as XGD. All others are same only. Here previously the early stopping will not make an processing, but here it will make an processing and it will end by the 10th or 11th approach itself. Here you may notice why, because the validation loss is not showing which very big difference. You may notice that 3.4, 3.5, only one 0.1, 0.2 difference is having with the validation loss. So this thing is that completed its execution by the 11th epoch itself, and then it is declaring the precision recall F1 score value, and we have got an accuracy of 48%, and also we have displayed the confusion matrix for SGD optimizer value. Then we are working with the rmsprop. This here also the only difference we will notice is the optimizer. Here it will be working for nearly, I think, 50 approaches. Yeah, it's working for 50 approaches. Here early optimizer is not working. With this RMS prop, we are getting an accuracy of 90%, and we have displayed the confusion matrix. In this work, we are working with Adadelta. The values of the layer composition are same only. Only the optimizer is different, which is Adadelta. Then we are making the fit function, and then here this early optimization is not working, and so it is working for nearly 50 approaches. We are and then we are getting an accuracy of only 50%. Then we are also making the confusion matrix plot, and finally you can now we are making an graph that is some comparison graph of all the four optimizers like Adam, SGD, RMS prop, and Adam W. Among that, you can notice that the training accuracy of SGD, which is blue color, with the Adam, which is only having the best accuracies. All others are showing some low accuracies only. Based on that, you can also see what is the others loss is also having. So this is the code for ANN with different optimizer. In the next video, we will be working with another optimizer. Thank you.